Now next chapter I am going to start is your earth pressure theories. So last class I have finished up to foundations, particularly mat foundations and different types of mountain foundations almost over, except that structural design. Now let us start with earth pressure theories. So let me start with example. Lateral fluid pressure, lateral fluid pressure is equal to gamma W into depth. Now soils and grains, particularly if I don't go the fluid, if I go by soils and grains, in this case possesses shear strength, it possesses shear strength. Then what will happen? Actually lateral pressure in this case is not equal to vertical pressure. Lateral pressure is not equal to vertical pressure, but it is only related to it. It is only related to it. Structures which hold back soil mass, I can say structures which hold back soil mass, particularly structures which hold back soil mass in a structure, that is called retaining structures. This is called retaining structures. So again retaining structures, various types: retaining wall, sheet pile walls, basement wall. Let us see these examples. So this is your retaining wall. What happen in retaining wall? One side it retain your soil mass, in one side it retains the soil mass. Here ground has been elevated from this surface to this elevation to this elevation, so that maybe road can be elevated from here to here. Part 1 A is your retaining wall. Second one, for example, like take it, bracing cot. This is our bracing cot. Then anchor sheet piles. In this bracing cot, what happen? This generally used particularly your tunneling or underground structures. Before, if you go below this brace cot, this side is your mass of soil mass. Then anchor sheet piles. Anchor seat pile has been used generally in port and harbor structures. What happened? Here there is a water table here, then your ship comes, berth it here, and people can go outside, and this side is your soil mass. So, particularly there is a soil mass which exerts on your anchor seat pile. This is your anchor seat pile. And this is particularly your anchor. Anchor has been provided in seat pile to prevent bending due to your soil mass, to prevent bending due to the soil mass. So, in this case soil can retain, you can retain the soil mass here, or you can retain the soil mass elevated from here, or you can do it here, retaining wall is there, or you can do it in this case either side, either you can retain this side or you can retain this side. If this is not the side you are going to retain, if you are retaining soil mass in this side, so in this case it is not necessarily soil mass should be horizontal, you can take a very steep slope also. This way you can go for a steep slope. So, soil can be retained on one side of the wall and it exerts the pressures on the retaining structures on the wall. So, what kind of pressure that we are going to discuss. So, this is about your earth pressure theories. Starting this, let me start with this effect of wall movement on earth pressures. Effect of wall movement on earth pressure. So, let me put it particularly when wall is rigid and unyielding. Retaining wall is rigid and unyielding. It is neither yielding in translation, rotation or any of the mode. The soil mass is in a state of rest. In that case soil mass is in the state of the rest. What will happen? Particularly this case there is no deformation and displacement. And earth pressure corresponding to this state is called earth pressure at rest. So, first one is your earth pressure at rest. If you look at here, first one is your earth pressure at rest. What does it mean? When wall is rigid and unyielding, the soil mass, particularly in that soil mass in the wall, periphery of the wall, in the state of the rest. In that condition what will happen? There will be no deformations as well as displacements. So, that condition we called earth pressure at rest. Now, let me put it two figures, let me draw two figures, it will be more clear to you. This is one. So, there is a wall here. Wall is, if I say this is my wall, wall is moving away from the field. this is fill. This is the wall, wall is moving away from the fill. So, in that case it is called active state, I wrote it PA. Let us say there is another wall, this wall is moving towards the fill, wall is moving towards the fill means this is the movement of the wall, this is the movement of the wall, this is the movement of the wall, wall is there moving towards the fill. Look at the diagram how this shearing resistance act. And this will be your PP. Let me start it first one. This is your case 1, this is your case B, case 2, this is your case 3. Let me start with this first one I have finished. Case 2, wall rotates about toe. In this case, wall rotates about toe. So, that means what does it mean? It means moving away from fill. Then the soil mass expand. What will happen? Suppose there is a wall here, there is a soil mass and it is moving away. So, this soil mass will be expand, then the soil mass will expand so it results decrease in earth pressure. It results decrease in earth pressure, mobilization of shear resistance in a direction opposing the movement of earth mass. Look at here, mobilization of shearing resistance in a direction opposing the movement of earth mass. And to move downward and outward relative to the wall. Downward relative to the wall. So, what will happen? First, wall rotate about the toe, this is my toe, wall rotate about the toe. So, because wall rotate about the toe, that means what will happen? It will moving away from the fill. So, inside the soil mass that will expand, that means decrease in earth pressure, mobilization of shear resistance in a direction opposing the movement, mobilization of shear resistance in a direction opposing the movement, because it is coming here, if you look at it is opposing the movement. Then there is a resultant decrease in earth pressure, a resultant decrease in earth pressure which continues until at a certain amount of displacement, failure will occur in the backfill and slip surface will be, then what will happen? Failure will occur. So, after that, after failure has been occurred, so forces acting the wall does not decrease, forces acting on the wall does not decrease. So, what does it mean? Even if there is further movement of the wall, the forces acting on the wall is not going to decrease. So, this is called your active earth pressure. Similarly, if I go, let us say, similarly the wall is pushed towards case C. If wall is pushed towards the your backfill, what will happen? Let us say case C, wall pushed towards backfill, then what will happen? The soil is compressed, and the shearing resistance built up in the direction towards the wall. Shearing resistance built up in directions towards wall. Then what happen? Earth pressure gradually increases. Earth pressure gradually increases and it will reach its limiting value. It will reach its limiting value, reaches limiting value, then your failure occur. This is called your passive earth pressure. This is called your passive earth pressure. If I draw how it looks like, if I draw a very simple way, this is my lateral earth pressure. I can put it lateral earth pressure. Then if I am drawing it, particularly this point, this is your active pressure, and this part is earth pressure at rest, and this will be from here to here, it will be passive earth pressure. So, I can write it here, it is away from wall and it is your towards backfill. This is away from the wall, this will be your towards backfill. If I put it, draw the lateral earth pressure, then if you look at passive earth pressure is much higher than your active earth pressure. Active earth pressure generated because wall moves away from the field. Passive earth pressure generated because wall moves towards the field. If I put it in a 3 parts, one is your earth pressure at rest. In earth pressure at rest, there is no deformation and displacement. Second is your active earth pressures. When wall rotate about the toe, at that time wall moves away from the backfill, that is called active earth, that is called second case B, where is your active earth pressure condition, that means wall is moving away from the field. If wall is moving away from the field, the shearing resistance to resist it, look at the directions, it will be the opposite directions. So, then it will reach its limiting state, failure will occur. So, at this condition, that is called your active earth pressure. Similarly, in case of passive state, wall is moving towards the field. If wall is moving towards the field, the shearing resistance is again opposite directions. So, in that case what will happen, earth pressure increases gradually, then it reaches up to the limiting value, then the failure occur, that is called passive earth pressure. If I draw in a diagram, this is my earth pressure at rest, this point is earth pressure at rest, this is your passive earth pressure, this is your active earth pressures. Now, next part is your earth pressure at rest. Earth pressure at rest. So, if you put it at rest conditions, so P0 is equal to K0 sigma z. Sigma z is your effective vertical stress at depth z. K0 is your coefficient of earth pressure at rest. Coefficient of earth pressure at rest. Then P0 I can write it, that is called your lateral pressure. If I take it, this is my ground surface, at depth z there is a soil element here. So, at that point the P0 lateral pressure is equal to K0 into sigma z. Sigma z is your effective vertical stress at depth z, K0 is a coefficient of earth pressure at rest. Let epsilon x is equal to strain in horizontal direction at depth z, strain in horizontal direction at a depth z. For a plane strain condition, epsilon x, which is equal to 1 by E into sigma x minus mu sigma z plus sigma x. So, earth pressure at rest means, what does it mean? There is no lateral deformation. That means earth pressure at rest epsilon x is equal to 0, then in this case sigma x is equal to mu by 1 minus mu sigma z. So, if I write it, sigma x is equal to a lateral earth pressure P0, which is equal to mu by 1 minus mu sigma z. Then this is nothing but is your K0. K0 is equal to mu by 1 minus mu. That means P0 is equal to K0 sigma z, which is equal to K0 gamma z. So, earth pressure at rest, it depends on your Poisson's ratio of the soil, that is your mu is Poisson's ratio, mu by 1 minus mu. So, P0 is equal to K0 into sigma z. K0 is your coefficient of earth pressure at rest, K0 is equal to mu by 1 minus mu. So, P0 is equal to K0 sigma z, whereas P0 is equal to K0 gamma z. So, values of your K0, values of K0, if I put it, write it soil, here it is your K0, dense sand, it will be 0.40 to 0.45, then loose sand, it will be 0.45 to 0.50, then mechanically compacted sand, it will be 0.8 to 1.5, then normally consolidated clay NC, it is your 0.5 to 0.6, then over consolidated OC, over consolidated clay, it is 1.0 to 4.0. This is standardized for soil. If it is earth pressure at rest, what is the value of coefficient of earth pressure? K0, dense sand 0.40 to 0.45, loose sand 0.45 to 0.5, mechanically compacted sand 0.8 to 1.5, normally NC is your normally consolidated clay, this is your 0.5 to 0.6, then OC is your over consolidated clay, this is 1.0 to 4.0. I think I will stop it here. Then next class I will start in details about the earth pressure theories, Rankines and Coulombs and detailed procedures. Thank you.